Okay, guys, so this is what you should come up with when you're finished. Again, this is just some practice looking at how you can find equivalent expressions when dealing with a one-trig function based on those formulas or those identities we just took a look at. Again, cosecant, we should have put a negative theta there, so that's a typo. Remember, cosecant of negative theta is equal to negative cosecant theta because cosecant is an odd function. All right? So any questions on how you can equivalently take some of these formulas and rewrite one of your trig functions? So this is what we're primarily going to be doing in this section. I'm going to be asking you to verify. So when verifying, or we can say proving, identities, the objective is to simplify one side to mirror the other side of the identity. This is the big key, guys, that you have to be really careful of. This is not an equation you are solving. You do not treat these identities like an equation. What that means is all the properties of equality are thrown out the window. In other words, what you want to do is you're going to pick a side. There is going to be an equal sign because the idea is you're going to pick a side and you want to manipulate it so that it looks exactly like what's on the other side. That's the goal. So that means you may not add, subtract, multiply, or divide to both sides of the equation. You may not cross-multiply. No properties of equality apply. Because, I had a professor in college that was really mean. Not every identity can be proved, just like not every equation can be solved. So the idea is, I'm not going to do that to you. Obviously, if I give you one, it can be done. But we would always have one or two in our test that could never be done. So you'd sit there for 10 minutes and you'd be driving yourself crazy. All right? So the idea is you want to manipulate one side and one side only. You want to work, again, like I said, these are just some strategies we're going to talk about. They are not equations. You want to work, pick the more complicated side, because there's going to be more stuff you can do with it. And what we're going to be concentrating on is replacing them with reciprocal, quotient, or Pythagorean identities. All right? A lot of times, if you have no idea where to get started, always try and rewrite with sine and cosine. That's always, especially when you're dealing with tangents. One strategy I'll recommend if you're stuck. You have no idea where to get started. Try rewriting everything in terms of sine and cosine and see if that helps. All right, so let's take a look at one. So I want to prove this identity. So in other words, I want to take this left-hand side of this equal sign, and through all the different formulas we've just talked about, how can I rewrite it down to just a secant x? So again, you're going to number your steps and you're going to justify what you're doing. Some may just simply be an algebra move. You may distribute. You may have to do FOILing. You may have to factor. So let's take a look at number 2a. First of all, just another hint. Anytime you see a 1 and a trig function to the second power, there is a particular formula on this blue sheet that deals with 1s and trig functions to the second powers. Immediately, what identities do you think we should look at? Try looking at your Pythagorean identities. All your Pythagorean identities are dealing with 1s and a trig function to the second power. So now look at 1 plus tangent squared. Is there a Pythagorean identity that is equivalent to 1 plus tangent squared? Yes, what is 1 plus tangent squared equal to? Secant squared. So that's going to be my first thing I'm going to do. So my step number 1. So again, everybody agree, like I said, you're picking a side and you're working with one side only. So I'm working on the more complicated side. So like I just saw on my blue sheet, cosine of x times by your Pythagorean identity, what I just showed you on the blue sheet, is equal to secant squared x. And that's a Pythagorean identity. So in parentheses, you will want to write what identity you used. Always keep an eye on where you're trying to get to. Remember, I'm trying to get this whole side to be written in terms of secant. I already have a secant squared right here, don't I? So the trick is, how can I get rid of cosine? Is there a way to get rid of cosine of x, rewrite it so that it's in terms of secant. Well, what's the relationship between cosine and secant? They are one of each other. Reciprocals. So go to your reciprocal identities. What is cosine of x equal to? Cosine of x is equal to what? 1 over secant. So that'll be the second thing I'm going to do. So cosine of x is equal to 1 over secant of x times secant squared of x. And that's your reciprocal identity. Now remember, secant squared of x is actually a fraction over 1. Now, at least I'm getting closer to my goal. Notice my goal is to get everything in terms of secant. Right now, everything on the left-hand side at least is in terms of secant. What happens when I multiply 1 over secant times secant squared of x? It's just going to be what? Secant x. And you're done. And here you just multiply. And you're done. Because now you have that secant x equals secant x. But that's what you're doing. So you always want to kind of keep an eye on where you're headed when you're doing these. Now let's take a look at B. Like I said, pick your more complicated side, and that's the side you're going to manipulate. So let's take a look at B. First of all, what side do you think you want to play around with? Which side is the more complicated side? The left side. So let's look at tangent x times cosine x equals sine x. So what are your thoughts? Any thoughts on how to get started? Well, what's tangent? So again, somehow, some way, I need to have this left-hand side become all in terms of sine. So what is tangent of x equal to? Tangent of x is equal to what? By your quotient identities. Sine over cosine. So at least that'll bring a sine in there. So step number 1 is I'm going to rewrite tangent as sine x over cosine x times cosine of x. And remember, cosine of x is actually a fraction over 1. And that's by your quotient identities. Now, what happens, so there's that sine of x I need. Now at least I have the sine of x on the left-hand side. So now what happens when I multiply sine of x over cosine x times cosine x over 1? What can you cross-cancel? Cosine of x. So what are we going to be left with? We're going to be left with a sine of x. And you're done. So that you just multiplied, or you could say you canceled. Okay? So any questions on B? Let's take a look at C. What side is your more complicated side? Left, exactly, the left. So we're going to work on the left. Now remember what I said in the first example. When you see a 1 and a trig function to the second power, what identities should you be looking at? You should be looking at your what? Pythagoreans. So again, what is 1 minus cosine squared equal to? 1 minus cosine squared is equal to what? Sine squared. And this is a Pythagorean identity. So notice at least now I have everything in terms of sine. So now what happens when you simplify sine squared of x divided by sine x? That's just going to become a what? Sine x. And here you just canceled. And you're done. So any questions on C? So notice what you're doing. You pick a side. You want to pick the more complicated side. You only manipulate that side that you pick. And you want it to become exactly the same as what's on the other side. So now let's take a look at D. What side is the more complicated side? The right side. You have two sets of parentheses. Both have a 1 and a trig function squared. So what identity should we go to? We should try going to what? Pythagorean. So what is tangent squared plus 1 equal to? Tangent squared plus 1 is equal to what? Secant squared. And 1 minus cosine squared is equal to what? Sine squared. So that's your step number 1, and this is your Pythagorean identities. Now remember, we're trying to get everything in terms of tangents. Well, by your quotient identity, what is tangent equal to? Tangent's equal to what? I'm trying to get you to think about your thought process here. What's tangent equal to? Sine over what? Cosine. So the big thing is there a way, there's my sine squared, so I'm good there. Is there a way I can change secant squared into a cosine? Well, what's the relationship between secants and cosines? They are what? Reciprocals. So then I can change secant squared into 1 over cosine squared x. Just like you did proofs with geometry. I need to see every single dingle little step that you're doing. I should be able to follow all your work. So notice right now I have an operation to do. All I did was I did a substitution. Now what can I do with these two fractions? I can do what? I can multiply. So when I multiply them together, that becomes sine squared x over cosine squared x. You can't just jump from 1 over cosine squared to sine squared of 1 and just write a tangent squared. I'm going to ask you in the proof, where did this come from? You have to pretend I have absolutely no idea what you're doing or what's going on. I should be able to follow step by step. You should be able to take your paper, show it to a friend, and they should not have to ask you the question, how did you go from here to here? If your classmate asks you, how did you go from here to here, that means you're missing some steps in your identity. So that's a good way to check to make sure you're doing very thoroughly in your identity. So now, what is sine squared over cosine squared equal to? Sine squared over cosine squared is equal to what? Tangent squared. And what's my reason? The reason is what? Quotient identity. All right, so any questions on those? So now, like I said, sometimes you're going to be rewriting in terms of just sine and cosine. So let's look at 3a. What side is the more complicated side? Jackson, turn around. Thank you. Put your phones away, please. Put everything away. Thank you. It's becoming very distracting. What side is the more complicated side? Left side. So now keep an eye on where we're trying to get to. Our goal is to get the left-hand side to be written in terms of sines. So what is tangent squared equivalent to? Tangent squared is equivalent to what by your quotient identities? Sine squared over cosine squared. And this is all over secant squared x. Now, you're dividing fractions, which means you can rewrite this as a multiplication problem. How do you divide fractions? You divide fractions by doing what? Multiplying by the reciprocal. So sine squared x over cosine squared x times 1 over secant squared x. And this is just your dividing fractions, or you can say multiply. So right here, guys, notice there's that sine squared x that I need. That's what I'm trying to get to. So now, what is the relationship between secant squared and cosine? They are one of one another. They are reciprocals. So what is 1 over secant squared equivalent to? 1 over secant squared is equivalent to what? Cosine squared. And what's the reason? The reciprocal identities. And then finally, what happens when you multiply sine squared over cosine squared times cosine squared? They're going to do what? They're going to do what? Cross out. So what are we going to be left with? We're just going to be left with our sine squared. And again, you can just say cancel or multiply. Okay? Any questions on A? You guys go ahead and try B on your own. I'll give you a hint. B is done very similar to the way that we did 3A.